Last class we discussed about the gravitational potential energy, gravitational potential, and the gravitational field. I refresh the concept once again. Gravitational field is a space around the mass in which the force, the attractive force, will be experienced. Gravitational potential is nothing but the work required to move the object from one point to the another point. Work required to move the object from infinity to the reference point is called work done or a potential energy. Expression of gravitational field is Gm divided by R squared, where G is the universal gravitational constant, R is the radius of the earth. Okay, M is the mass of the earth. In the case of gravitational potential, the formula is minus capital M divided by R. The potential energy, the expression will be minus G capital M small m divided by R. Today we are going to solve the problem related to potential, gravitational potential energy and potential field. Okay. Can you see the screen, students?
Yes, sir.
Okay. See the first problem. The mass of the earth is 6 into 10 to the power of 24 kg. The potential energy of the body of mass 50 kg at a distance of 6.3 10 to the power of 9 meter from the center of the earth. That is the question. Question is find out the potential, that is a gravitational potential of mass 50 kg at a distance of 6.3 into 10 to the power of 9 meter from the center of the earth. How to find out? You have to consider the mass of the earth and the mass of the body. It's a direct question. The gravitational potential energy is denoted by the letter U. The expression is minus capital G, capital M, small m, divided by R. Now substitute the value of G. What is the G value?
6.7 minus 11.
Okay. 6.7 into 10 to the power of minus 11. What is the mass of the earth? That is the given.
6.1.
What is the mass of the body? 50.
50.
What is the radius?
6.3.
Actually, the body is 50 kg placed at the surface of the earth. Therefore, the distance here is the radius of the earth. What is that? 6 point. Now, try to simplify this and tell me the answer, please. Try to simplify this and tell me the answer. See the option, how to solve the problem quickly. See the option, the exponent are 10 to the power of 9, 10 to the power of 6, 10 to the power of 11, and 10 to the power of 6. You can roughly do it. See here, 6.7, 6.3. Consider is equal. It will be 6.7, 6.7, approximately 1. Let it be. Here, it is a power 9, no? Come to the numerator, it becomes 10 to the power of minus 9, minus 11, minus 9, minus 20. Already here, plus 24. The remaining is 10 to the power of 20. Already here, sorry, 10 to the power of 4. Understand? Here 10 to the power of 9. When this power comes to the numerator, it becomes 10 to the power of minus 9. Minus 9, minus 11, minus 20. Here the power is 24. When you subtract that power, it becomes 10 to the power of 4. Okay. Here also one power is there. That is what? 10 to the power of 5. When you multiply this one, 6 into 5, 30, in which another one 0. Therefore, it becomes 10 to the power of 6. Here, there may be an answer. And when you multiply 6 into 5, that will be approximately 3. When you consider this 6.7 and 6.7 are equal, no. Therefore, approximately the value will be minus 3.19 into 10 to the power of 6 Joule. That is the method of arriving the answer very quickly in a short span of time. Understand the student?
Yes, sir.
Because they are asking the options only. It is not required to calculate the entire thing. Okay. Anyway, you do it the problem. This is the method of arriving the answer very quick. The approximate. After writing this, kindly inform me.
Yes, sir.
Students, see this again. Next problem. The change in potential energy when a body of mass m is raised to the height nr from the Earth's surface is change in potential energy. That means what? Delta U. That is the final potential energy minus initial potential energy. Consider a mass is placed at the surface of the Earth. It has its own potential energy. When it is raised to the particular energy, the potential energy will be increased. The potential energy is the energy due to the position of the body. How much height is raised? Height of the object is n naught. N times the radius of the Earth. That means now substitute the distance as n naught in the second case and find out the difference. You will get the answer. Try to solve this problem. I'll do all. Simultaneously, you have to do the problem. Then only you can get the practice First, potential energy at the surface. What is the formula? Minus G capital M small m divided by R. The body is raised to particular height. What is the radius height? Already one height plus NR. Understand? Okay. Now next del U. Subtract these two value minus G capital M small m divided by capital R NR minus of minus G capital M small m divided by R. Okay. The minus of minus becomes plus. See, in the first case, the first expression, see, there are two R's, no? Take it outside R. It becomes 1 plus N plus. Okay, take the LCM now. Let us take G capital M small m divided by R as a common value. First term becomes 1 plus N. Isn't it? Then plus 1. Then students, listen here. See the expression, final answer, capital G, capital M, small m divided by capital R into N divided by N plus 1. See the answer. This answer is not relative to this. Okay. Therefore, see the options. Options are in terms of G. What is the G value? Acceleration due to gravity. You know that G formula? Anybody? Acceleration due to gravity? Gm divided by R squared. So, to reach this expression in terms of G, let us multiply and divide the expression by R. So, in the denominator, this R and R becomes R squared. Okay. And then into R dividing N plus 1. Now, the final answer becomes, we can express this first term. See this one. Now we can be expressed in terms of G, isn't it? G R M and then yes. See the options. Which one is correct? Yes, very good. So depends upon the option given. You have to modify your answer after solving the problem. Understand, students?
Yes, sir.
Okay. Kindly note down this, please, quick. Have we finished, students?
Yes, sir. Yes, sir.
Okay. See the next problem. A particle of mass m is placed at the center of uniform spherical shell of mass 3m and radius r. The gravitational potential on the surface of the cell is gravitational potential on the surface of the cell. I explain the problem. See, A particle of mass is placed at the center of the uniform spherical shell. Shell means like a ball, a football, in which there is a vacuum space. The material is a very thin layer of the material. Okay? A hollow one. Hollow sphere is nothing but the spherical shell. Understand? In which a particle of mass m is placed at the center of uniform spherical shell of mass 3m. Oh, 3m is the mass of the spherical shell. M is the mass placed at the center of the spherical shell. The gravitational potential on the surface of the cell. This is very important point. Actually, gravitational potential, it is denoted by the letter V. When the system consists of n number of masses, the total gravitational potential is the summation of V1 plus V2 plus V3 like that. The formula is, what is the formula?
V is equal to Cm by R.
R only. Minus I. Okay, va? Okay. Now, all of you listen here. Now, I am going to calculate the gravitational potential for the mass m. Enga calculate பண்ண போறேன்? At the surface of the cell. ரெண்டாவது பாயிண்ட் தான் ரொம்ப இம்பார்ட்டன்ட். நெக்ஸ்ட், இந்த மாஸுக்கு எங்க கால்குலேட் பண்ணணும்? இங்கே தான் கால்குலேட் பண்ணணும். வாட் இஸ் த டிஸ்டன்ஸ்? இல்லையே, ஸ்மால் மாஸுக்கு டிஸ்டன்ஸ் வந்து நம்ம ஆர்னு போடலாம். This is the radius of the cell. Say it is given capital R. We can find out the gravitational potential. But what about the gravitational potential for the spherical shell? This is very critical point. We have to calculate the radius. Actually, even though it is a hollow one, the center of mass will be at the center of the spherical cell. Understand? The whole mass of the spherical cell will be concentrated at its center. Therefore, we have to assume that this mass is concentrated over here. Understand? Therefore, the distance will be again R. Yes? Any doubt? Okay. This is a very critical point about this problem. Now, let us calculate V1 and V2 one by one. What is the electrostatic, gravitational potential formula?
V is equal to
Minus capital G, capital M divided by. Now, the total gravitational potential about the spherical cell is the sum of the gravitational potential for the mass M. Let it be 1. Rend. V2. V2 is the gravitational potential of the spherical cell with respect to the center of mass. Now substitute the values in the formula. V1 minus capital G. M here.
3m.
Huh? First one.
M.
3m. I'm talking about a small m. Small m. V1 is the gravitational potential for the mass placed at the center of the spherical cell with respect to the outer surface. Distance is R. V2 minus G into 3m இங்க தான் 3m வரும். சரி, இப்போ இது ரெண்டையும் நீங்க ஆட் பண்ணி சொல்லுங்க பாப்போம். குயிக். minus g small m divided by r minus g 3m divided by r. 3m plus 1, 3 plus 1 na 4 ah? So minus 4 divided by r. What is the correct answer? Yes, very good. Okay, take down these please. Finished?
Yes, sir.
See this next problem. This one. A body of mass m rises to the height phi r from the surface of the earth. If g is the acceleration due to gravity at the surface of the earth, the increase in potential energy. The increase in potential energy. Already one mass is there. It is placed at the surface of the earth. That mass is raised to the particular height. That height is equal to the 5 times of the radius of the earth. Then what would be the increase in potential energy? That is the question. This is also a very simple problem. You can do it. Tell me the answer quick. Increase in potential in energy is nothing but the change in potential energy U2 minus U1. The initial potential energy of the body placed at the surface of the earth is minus capital G, capital M, small m divided by R. U2 minus G, capital M, small m. Now the distance is increased from the surface. How much? 5 times. The height to which the body is raised is 5 times the radius. Therefore, it becomes what? In the denominator. Now subtract this 2 value. Minus G, capital M, small m divided by 6R. Minus of minus plus, no? One by 6 minus 1 is what? 5 by 6 G M R. Correct? Option, which one is correct? See, here also, all of you listen here. See the options. All the expressions are in terms of G, but our answer is in terms of G, M, small m divided by R. Therefore, the answer is modified in terms of G. What is the formula? Capital G, capital M divided by R squared. Therefore, this value is multiplied by capital R and divided by capital M. It becomes 5 by 6 G capital M small m divided by R squared into R. This value is equal to what? G. Therefore, 5 by 6 already on a small m G R. Yeah. Therefore, the answer is B. Note down this. Okay. Option B. Have you finished?
No, sir.
Okay, let us go to the next problem.
Yes, sir.
Huh?
Yes, sir.
Students, see the next problem. The work done in shifting the particle of mass m from the center of the earth to the surface of the earth is work done in shifting the mass of m from the center of the earth to the surface of the earth is, what is that? What does it mean, work done? It is nothing but the gravitational potential energy. As per definition, the work required to move any mass from one point to the another point is called gravitational potential. The corresponding energy, gravitational potential energy. Therefore, the work done is nothing but the gravitational potential energy. The difference of potential energy is called work done. Understand? Work done is equal to final potential energy minus initial potential energy. See these options. All the options are in terms of G. Therefore, we have to convert that answers in terms of G. Let us find out the initial potential energy. The mass is moved from the center of the earth. Therefore, potential energy about the center of the earth, what is that? Anybody? At the center of the earth. In previous class, I have given the relation between the potential energy of the center of the mass and the surface of the mass. Refer the formula. Refer the formula. V center is equal to 3/2 of the surface, isn't it? The gravitational potential at the center is 3/2 of the gravitational potential at the surface, the V surface. Using this relation, we can calculate the gravitational potential. Sorry, the sound is coming from outside. Okay. Now, the U1 is related to the gravitational potential with respect to the center of the earth. When V is multiplied with the corresponding mass, it will be a gravitational potential energy. Therefore, 3/2 capital G, capital M, small m divided by R. Correct? Now, this can be expressed in terms of small g, acceleration due to gravity. What is the formula? Yes, very good. Therefore, the above expression is modified in terms of G, R multiply பண்ணுங்க, divide பண்ணுங்க. 3/2 G M by R squared into M R. This is equal to G M R. This is the first expression. Similarly, find out the initial expression, initial potential energy. Can you tell that initial potential energy? Anybody? Initial potential energy at the surface of the earth. What is that? Minus G capital M small m divided by R. This can be written as in terms of G as minus mgr. Now subtract these two values, we'll get the answer. Work done. See this one, final one. Minus mg r minus of minus 3/2 g. Here put the minus sign here. Students, note this point, minus sign here, minus sign. What is the answer when you subtract this two quantity? Option B. Yes. mgr divided by 2. Yes. Shall we go to the next problem? Okay, I'll wait. In the next class, we are going to analyze the satellite, escape velocity, types of satellite. With that, the gravitation chapter will be over. So kindly revise all the topics I taught in the previous classes. I'll ask questions. Okay, next problem. If g is the acceleration due to gravity on the Earth's surface, the gain in potential energy of the object of mass m raised from the surface of the Earth to the height equal to the radius r of the Earth is. It's similar to the change in potential energy. You can try. G is the acceleration due to gravity on the Earth's surface. The gain in potential energy of the object of mass m raised from the surface of the Earth to the height equal to the radius of the Earth is. The question is, find out the change in potential energy when a mass is raised to some particular height. That height is equal to radius of the Earth. How to solve this problem? Very simple one. Kindly do that. Gain in kinetic energy is also difference of kinetic energy. Sorry, gain in potential energy is final potential energy minus initial potential. Potential energy at the surface of the earth. Yes. Can be expressed in terms of G as minus m g r. Now that mass is raised to the height equal to the radius of the earth. Therefore, the potential energy changed. Potential energy at a distance r from the surface of the earth minus g capital M small m divided by the height becomes from the surface. What is this? R plus R plus R. Yes, 2R. Expressed in terms of G minus G small m R divided by 2. By multiplying R, dividing R. Gain in tell me the answer. Option? Okay. Option வந்து எது என்ன வந்தது? Which one is?
Yes, sir.
Okay, very good. Okay.
Option C.
See the first question, students.
So first question already solved.
Solved.
Yes.
Do this problem. At what height h above the earth's surface, the value of g becomes 3 by 2. Very simple question. You can do this. Surface le G value. எவ்வளவு height போனா the acceleration due to gravity half of the value of the gravitation with respect to the earth surface. I'll give 1 minute. Tell the answer quick, or otherwise I will do it. The acceleration due to gravity at any height. What is the governing formula? G. Tell me the answer. Formula. Isn't it?
G
Gravitational at any height. Gravitational acceleration at any height, GH is equal to, in terms of G, R divided by capital R plus H whole square. In the problem, at a particular height, the acceleration due to gravity is half of the acceleration due to gravity at the surface. Now, substitute G suffix H as G by 2 and G R divided by R plus H whole square. Understand? From this expression, we can calculate the, what is that? Height. Simplify this. GG get cancelled. This side 1 by 2 R divided by R plus H. Take square root R both side. 1 by root 2 R divided by R plus H, isn't it? Now R plus H, cross multiplying it, root R, correct? Now next say is equal to root R minus R. Take it outside R, root 2 minus 1. That is H. Which one is correct? Yeah. In the next class, we are going to analyze the escape velocity and the types of satellites. We will complete this gravitation by the next class. After that, we will start the new chapter. Students, kindly revise all portions when you come to the class. Then only you can succeed in the examination. Do the problem, same problem at home to get the practice and get the idea. Have you finished?
Yes, sir.
Okay. With that, we conclude today. We will see in the next class. Thank you for attending the class. Thank you very much.